A wise man once said, with great power comes really big numbers. Hey there guys, welcome back to another video, and if this is your first time here and you're aiming to get the best graded maths possible, start now by subscribing and clicking the bell. Lots of useful content is coming your way. Okay, so this is one for everyone at GCSE Maths, Higher and Foundation, and also the start of my Indices playlist, which is linked down below. So in this video we are going to look at the basic rules of indices. I'm also going to at the end show you why any number to the power of 0 is equal to 1. We are going to go through examples of using each rule separately, but then we're going to combine them into trickier problems. Now, throughout this playlist, I'm also going to put together some PDFs of questions that I make up, and also past paper exam questions, which you will be able to download. Further on in the playlist, we'll get to the more complex indice stuff, such as negative and fractional powers, as well as solving equations with indices. Very first thing we're going to do here though is look at what indices or powers actually are, because it so often gets taught wrong, which is probably why so many people find them confusing. So, what do I mean by that? Well, you've probably been taught that an indice or power tells you how many times to multiply a number by itself. That is not true. Okay then, so what do they actually mean? Well, let's have a look at if they did mean how many times you multiply a number by itself. So let's start with 3 squared. Now, if that meant to multiply 3 by itself twice, that would mean we start with 3, and then we're going to times that by 3, so we multiplied 3 by itself once, and then we would do it again. Now that is 3 multiplied by itself twice, and that is wrong. What it actually means is how many times you multiply 1 by the number. So 3 squared actually means 1 times 3. So we multiplied 1 by 3 once. We got a power of 2. So we need to do it twice. Now, of course, in practice, we don't really bother writing the 1 at the start, but for the next few examples, I'm going to just try and demonstrate what the power really means. So, 3 squared, 1 times 3 times 3 is of course just 3 times 3, which is 9. Let's say we wanted 2 to the power of 5. So that means 1 multiplied by 2 5 times. So that's 1 times 2, there's once, times 2, there's twice, times 2, there's 3 times 2, 4 times, one more time, times 2, there's 5 times. Again, really, we don't bother with the 1 at the start, So this is 2 times 2 times 2 times 2 times 2, which is 32. Okay, one more. Let's do 3 to the power of 3. So that means 1 multiplied by 3 times. So 1 times 3 times 3 times 3, which is just 3 times 3 times 3. Now 3 times 3 is 9, 9 times 3 is 27. So that's what's really going on with indices. It's the amount of times you multiply 1 by a number, not how many times you multiply a number by itself. Okay, so one last thing to mention before we hit the rules is that any number written without a power is that number to the power of 1. For example, 5 does have a power, it's 5 to the power 1. Because of course it means 1 times 5 once. 10 is 10 to the power 1. 2 is 2 to the power 1. In general, a number A is that number to the power of 1. Now, it's a boring power, it doesn't do anything exciting, so we don't bother writing it. But it is important to know that a number written on its own is that number to the power of 1, because it's going to come in handy when we hit the rules. Okay then, so these are the 3 main rules. Everything else we do with indices comes from these. So, when you set a number to a power, the number on the bottom is called the base. To combine indices, the base of terms must be the same. So, for example, this top rule, the base is a, so we have a to the power x times a to the power y. Now we can combine those because they have the same base, which is a. So a to the power x times a to the power y is a to the x add y. A to the power x divided by a to the power y is a to the x minus y, and then a to the power x to the power y is equal to a to the power x times y. So when powers are separated by a bracket, they multiply together. So these are the rules, let's use them. Okay then, first up, we're going to play around with a to the power x times a to the power y is equal to a to the power x add y. So, let's do some examples. So, first of all, let's say we start with 2 times 2. And let's say that we want to write that as a power of 2. Well, remember what I just said about a number written without a power is really that number to the power of 1. 2 times 2 then is 2 to the 1 times 2 to the 1. Now by the rule, we add the powers, so we get 2 to the 1 add 1, which gives us 2 squared. let's say we have 3 to the power 5 times 3 to the power 7. Well, that's going to be 3 to the 5 add 7. Which is 3 to the power 12. Now you don't just need to have two terms, so we might have something like 5 squared times 5 cubed times 5 to the power 9. The rule is the same, we just add all the powers together, so we're going to get 5 to the 2, add 3, add 9, which is 14. 5 to the power 14. Let's say that we had something like 2 squared times 3 to the power 4 times 2 to the power 7 times 3 to the power 4. So, with this one, we have two different bases, 2 and 3. So we can't combine this whole thing into one single term. But what we can do is combine the 2's and combine the 3's. So you might, first of all, want to rewrite it as 2 squared times 2 to the 7 times 3 to the 4 times 3 to the 4. So that's going to give us 2 to the power 9 times 3 to the power 8. So there's nothing else we can do there with that one because the bases are different. It's very common with indices questions that instead of numbers as the base we have algebra. Nothing to be scared of, so at Excel in particular I love to use m, so let's say we had m to the 3 times m to the 5 times m to the 8. We just add across the powers, so we're going to get m to the 3, add 5, add 8, which is m to the 16. Okay, so hopefully this has given you a feel for how this rule works. Next up, the old division rule. So a to the power x divided by a to the power y is a to the power x minus y. Now something to look out for here is that divisions are fractions, so sometimes this might be presented as a fraction. So you might be given something of the form a to the x over a to the y. That means a to the power x divided by a to the power y. So that, again, is a to the x minus y. So, for example, we might have 2 to the power 9 divided by 2 to the power 3. That's 2 to the power 9, take 3. Which is 2 to the power 6. We might have 8 to the power 7 over 8 to the power 2, and that's 8 to the 7 minus 2, which is 8 to the 5. Again, they love getting algebra involved, so we might have x to the power 11 divided by x to the power 7. That's going to give us x to the power 4. They might give us y to the power 20 over y to the power 13. That's going to give us y to the power 7. Cool. What about if they give us something like this? So say we had a squared b cubed. So that means a squared times b cubed. What about if we then had that over ab? So, when you're playing around with indices, again, you can only combine terms with the same base. So, a's can only affect a's, b's can only affect b's. So, all we do is going across on the top, we start with the a term. So we have a squared. Now on the bottom, we have a. So that means a to the power 1. So we can do a squared divided by a to the power 1. That's a to the 2 minus 1. That's just a. Okay, so that's the a's done. We can now play with the b's. So now we have b cubed divided by b. That's b to the power 3 minus 1. That's b squared. Hopefully there will be more like that in the next video, where I'm going to go through and find exam questions. And the final rule, so a to the power x all to the power y is equal to a to the power x y. So let's think about why does this work. Let's say that we had 2 cubed to the power 2. Now 2 cubed to the power 2 means 2 cubed times 2 cubed. And then we know by the first rule that we just add the powers, it's 2 to the power 6. So that's how this rule works. You don't need to bother doing that middle step. It's just to show you where it comes from. So let's say we had 3 to the 7 to the power 5. That would be 3 to the 35. say we had x to the power 10 to the power 2, and that's x to the power 20. Now the way that these can get a little bit scarier is if you have something like a squared b cubed to the power 4. So there's now two terms in the brackets. All that happens is the 4 multiplies the power of each term, or not term, each base separately. So we're going to get a to the power 2 times 4, which is 8, times b to the power 3 times 4, which is 12. This works if you have a fraction 2. So say we had a squared over b to the power 5 to the power 10. All that happens, both powers inside get multiplied by 10. So we get a to the power 20 over b to the power 50. Okay, now then let's combine the rules. So, first up, let's just go for something like x to the power 7 times x to the power 5 divided by x to the power 9. So, remember from bitmass, division and multiplication happen at the same time, so we can just work left to right. So, we could first of all combine x to the 7 times x to the 5, so that's x to the 12. So we have x to the 12 divided by x to the 9. That then is x to the power 3. Okay. Now, something like a to the power 6 times a to the power 5 to the power 10. Okay, bitmass, do the stuff inside the brackets first. So this is going to give us a to the power 11 to the power 10, which is a to the 110. Let's go for a to the power 10 divided by a over a to the power 2 times a to the power 3 all to the power of 2. Okay. So it looks like a monster, just break it down. So do the stuff inside the brackets on top and bottom first. So we're going to get a to the power 10 divided by a is a to the power 9. On the bottom, a squared times a cubed is a to the power 5. So that is all being squared. Now, again, do the stuff inside the brackets. So do the division. So this is a to the 9 divided by a to the 5 is a to the 4. Now that is to the power 2. So that's a to the power 8. Okay, so that's it for questions in this video. There's going to be more in the next, which is going to be exam questions. To finish off, we're going to show you why any number to the power of 0 is equal to 1. Before we do that though guys, if you've got this far in the video, hopefully you found it useful. Don't forget to give us a thumbs up, get subscribed, drop us a comment, share with your friends because they might need help too. If you want particular topics covered like this, let me know down below in the comments. Okay then, so why is this true? Probably seems a bit strange, maybe seems more like the answer should be 0. Well, remember at the start of the video I told you an indice or power tells you how many times to multiply 1 by a number. Well, if you have an indice of 0, then that's telling you to multiply 1 by this number 0 times. Now that's not telling you to multiply 1 by 0, it's just essentially telling you to start with 1 and then do nothing to it. So your 1 is going to stay as 1. There's another way of thinking about it. So, hopefully we know that any number divided by itself is equal to 1. For example, 2 over 2 is equal to 1. Pi over pi is equal to 1. Let's generalise this and do a to the power of x divided by a to the power of x. So that's some number divided by itself. Now we know that that then has to equal 1. Now in terms of the indices, we know that a to the power x divided by a to the power x, well that's a to the power x minus x, which is a to the power 0. Now we've just shown then that a to the x divided by a to the x is 1, and a to the x divided by a to the x is a to the power 0. Therefore, a to the power 0 does indeed equal 1. There is one exception, one number that this doesn't work for. Let me know what you think it is down below in the comments. And guys, I really hope you enjoyed this, found it useful. The next video in the playlist, which will be linked down below, is going to be a selection of GCSE 9 to 1 Maths past paper exam questions from AQA and Edexcel that you will be able to download. Take it easy, take care, have a great day.